So this is a real project. It's applying AI as part of a feature in an existing project. It's not development focused like a lot of the other stuff. So hopefully this is something that's a bit different, a bit more interesting, maybe. But anyway, so I'll go through what we are doing on the project generally, the problem we're trying to solve with AI here, and it is to do with templating. So we'll talk about some of the features of templating that make this a good problem to solve with AI. Then go through what we've built, show it off a little bit, and talk about the future. So this is a project for a meteorological organization looking at their operational meteorology workflows. So operational meteorology is delivering weather insights from meteorologists. Typically, this is done in the current systems through what they call forecast products, which are wrapped up in services. But the product, the file that's delivered or the data that's delivered is kind of the key thing here. So these services have varied inputs. There are weather models, math models, physics models, which are deterministic or probabilistic in various ways. They generate masses of data. But there's also human-generated content out there as well, stuff that the forecaster writes, to be read out on the news, for example, or something like that. And these products also come in varied output formats. So these file formats also, but data, audio, video, content in lots of different ways. They can also be the same product, just presented slightly differently. So it might be delivered both as a data file, an XML file for ingestion by a machine, but the same content delivered as a text file or a PDF or something for a human. And these products exist in a load of different contexts for the organization as well. So they've got their own customers, they've got other public sectors services like MOD or airports or various other people and places. And each of these sectors has its own particular constraints. So there are a lot of regulations, for example, in the aviation sector or the marine sector. There are slightly fewer constraints on things like media, but you still have things like time. You know, there's no point a meteorologist writing a 40-page document to be read out in a 30-second slot on the news. So we've got to work inside this massive problem space, lots of variability. And someone thought that they could do all of this in one system. Right now, it's implemented with a whole lot of Visual Basic macros behind Word and Excel and all sorts of other things, and it's quite horrific if you dig into it. So we're basically doing a sort of cloud transformation modernization project, but also building for the future. What can they do with this system after they've done what they're doing now, but better? So are all these products on the screen the same? You've got the standard sort of text-based 5-day weather forecast. You've got a massive data product with a table of wind speed and temperature and pressure and things. And we've also got graphical elements as well. So these are perhaps a meteorologist drawing fronts on a map based on what the weather model has produced, and then annotating it with forecast information alongside. So we built a system to do this. We have a templating engine. It is very powerful. It's captured all of the variability in that problem space, all those different types of inputs, all those different types of outputs. And basically, we're wrapping this up so a template is a big data object. But it's a very detailed data object, and you've got to get it just right. So there's no point having something in your output that consumes data that wasn't provided by a meteorologist in the inputs. Or there's no point having an input, say, for a weather model data table that is missing a parameter for its location or its time. You've got to get it all right. There's a lot of controls to do, and filling in one of these data objects through a web form is quite cumbersome. And it doesn't scale very well. The more you're doing with it, the longer it takes and the more precise it has to be. So our template authors reckon that it could take quite a while to do one of these for a new product. It's not necessarily all template creation. They've also got to think about tasking. You know, when is the meteorologist going to do this? Twice a day, once a week? Is it fixed? So Wimbledon has forecasts, for example. You don't need those in winter. So all of this stuff needs testing, but a large part of it is the template and the template complexity. So the opportunity here is, can we make this more efficient? So the big form on the right there, some of the example products they have dozens and dozens and dozens of inputs to be configured. These would be things like the weather today for 30 words and the weather tomorrow for 30 words, spread across 5 different regions in one product. Can they do this more efficiently? So to take a small step back and look at the kind of the technical underpinning of this, what is a template? As I sort of hinted at, it is content. It's varying content that's produced by systems or users, plugged into something. and it spits out a result which varies according to that content. And the idea is that this is deterministic, that the template does something, it transforms that content and gets the same result for the same content or different results for different content, which means it looks a lot like a function. So we talk a lot about code. A template is basically just a code function. It's got inputs, it does something to them, and you get an output. And in our case, as I've said, we're strongly typed. We've got different things that we know about those inputs and things we know about the outputs. So a text input could have a maximum word count or a maximum character count. Data might have maximum rows in a table or something like that. There's constraints, there's configuration. Some of these things might be requests to external services, so talking to the weather models, getting data out of them, or rendering that in the output. So a table could be rendered with zebra striping on the rows, or bold headers, or lines or no lines, all that sort of stuff. And we have layers of dynamic behavior in these templates as well. So we have this template system where we have a data object describing all this stuff, the inputs and the outputs. Parts of those can be dynamic too. So we have handlebars templating language in there for expressions and text templating. We're also using a typesetting engine called Typest, which is a bit like LaTeX, if anyone's used that, but it's much simpler. But there's different layers of this, but fundamentally, it's a function. It's kind of like code, which means LLMs are pretty good at it these days. So we're hoping to make this better, deal with all this powerful stuff that we've got in a more simple way. So the workflow that we're designing here is basically much as we've seen a lot of today, a prompt fed into a workflow, out of which we get our Vortex template. Vortex is our product, by the way. So the data object that we have has these different subparts. You've got the product definition describing the inputs, the product layout describing the outputs. Each of those has a schema, and the subparts of it have their own schemas, and so on and so on. So we need to get something that matches that exactly out of the other end. But this is just a translation layer fundamentally, and that's another thing LLMs are pretty good at. So the workflow that we've built, we've called it an agentic workflow. It's not purely agentic, really, if you squint a bit. At a higher level it is. Internally, we're not actually using agents. We're just making calls to LLMs, wrapping them in a Python app, and doing some deterministic stuff around them. But that's one approach. We could do it a different way. I'm sure you could. But it works. So the first step is to take that prompt, extract the content, work out what the user is asking for, and turn it into what we call the intermediate representation, the IR. And then we can offer the user the ability to kind of step into the workflow here, validate that understanding, make sure that the workflow engine, the tooling underneath, has understood that prompt correctly, give them the chance to edit it and feed it back through if it's wrong, or just approve it and move on to the next step. So the next step is to take that IR, the intermediate representation, and turn it into a data transfer object. So this is the strict schema mapping to our Vortex API. So we're using a framework called LangGraph, and that can make calls out to all the other LLM providers and things. And one of the parameters on there is called structured output. So you can say, I want my response in this format, this JSON structure, this JSON schema. So we're using that a lot. And we actually work through this in a chunked way. So we break the intermediate representation apart and say, I need to produce chunks of my output, my DTO. I can do all those in parallel, or I can do some sequentially. And then we join them all up at the end. So we can do, we've kind of broken this apart, as was mentioned in the last presentation. You break it apart into small pieces, and the tools get a lot better at it. So these incremental steps improve the accuracy against our target architecture, so the specification for our API, the DTO. We get much better results by doing smaller pieces. We get stability with smaller models. There's no point feeding this into a massive 30 billion parameter model. And in fact, we get much better results on 1.5, 3 billion parameter models, much smaller, much cheaper. And it's kind of almost deterministic now. We've constrained so much of this problem space in terms of the output and the validation around it that it's, we're not getting too much in the way of hallucination. We get the same or very similar results out every time, which is really valuable because it means you can trust it more. We're doing this through a combination of sequential LLM calls with templates for the prompts, system prompts, and we have a validation loop, deterministic Python code that anyone could write, the old-fashioned way, validating the response and then feeding it back through again if there's a validation error. So if it said, let's say on tabular output table element in the layout that it thinks it's an image and it gives the wrong configuration option. We validate that and we feed it back in if it's wrong and does the right thing next time. And we've got that human in the loop still, so they validate as well. So hopefully the videos will work slightly better today. But this is what we built. Framework is called Streamlit. It's a Python web framework. It's good for hooking up to Python code behind the scenes. So yes, you've got your standard prompt entry here. So this is some pre-canned stuff. You tell it what you want. You give it as much information as you can. So we're talking about things like, in this case, there's a variant, a morning and an afternoon issue that are slightly different. You describe what you want in terms of the output in as much detail as you can. We've deliberately left it kind of unstructured, but we can configure the workflow to, say, use different models if they're better or worse, to configure the temperature, the randomness in the content extraction phase, and I've said that I want to pause and review that intermediate representation. If you trust it, you can just let it run through and validate the final result. So hitting the run workflow, it doesn't take very long. You know, some of the coding agent stuff that we've talked about today, you know, it runs for 15 minutes, half an hour, hours sometimes. This takes about 8 seconds. And then I can review this intermediate representation. So it's a data object that looks quite a lot like the Vortex API, but a little bit simplified. Easier for a human to understand, so they can look at this, they can check that it's right, that it's understood the intent, that there are different variants, that there's conditional behavior it has to encode. And you can see if it's wrong, you can edit it. So I've decided that I would like this data container, this text input, to be presented to the meteorologist up here between these two rather than at the bottom, because it makes more sense according to my requirement. Key thing with all that prompting is that that's information that already exists. You know, the organization has specifications for all these products, so they're not doing anything completely new here. Once we're happy with the intermediate representation, we can move on to the next step, generating the DTO. It does very much the same thing, except it breaks it apart into chunks. It retries if it fails. You can see cost estimation at least. And this is now the object that is compliant with our Vortex schema, with our API schema. So we know it will be accepted. It may not do the right thing, but it'll be accepted. We can check the content easily here as well, so I can see the handlebars expressions all look right. I can see the content matches what I prompted it with. And once I'm happy with that, I can scroll up and hit the Go button, and this is linking now to our Vortex tool. So integrating this with our actual application that the users are already getting familiar with is really valuable. They can do stuff with this now. And I'll skip through this because it's just what we've built already. But this is the UI they're already familiar with. They can validate the same content here. They can run through our standard kind of development, template development workflows. They can preview it. They can check the output looks correct. Hopefully I can skip to the next one. Right. This is just another example for a slightly more complex product with a data table in it. So I've had to be a bit more precise here because the Vortex system talks to another API to consume the data from the weather models. So we've said, use this model, use this collection. You know, it's over the UK. It's an atmospheric model, not a surface model. I've said I want which data parameters, the weather parameters, temperature, pressure, wind speed. Lay them out this way, run conversions, all the things that you'd have to define in your product specification anyway, just in a slightly structured way. And we can see that the output that we got has translated it correctly, as of course it would, because this is a nice demo. And we can see here, this is what the user would have had to do by hand if they were doing this. They would have to click through this massive UI form, process which of the parameters they want, select them, choose a conversion for each one, choose a rounding for each one. You know, potentially dozens, hundreds of clicks just for this one product. And as I say, if it's slightly wrong or slightly inconsistent, it can really fall apart. So what did we get out of this? Our template authors are quite excited by it. They think that this could save quite a lot of time. So from that 6 to 8 weeks, maybe 1 or 2 weeks could be template authoring at the beginning. We think that could be reduced down very, very shortly. Very short, yeah, to a small number. And that should scale better for more complex products. So when you've got different tables, different data sources, different data types, different output types, this should get a lot easier to work with. And that means that they can do more things as an organization themselves. They can prototype things, they can sell new stuff to their customers, they can offer new things to their customers more rapidly. And that kind of unlocks a lot of future capability for them. So there's a lot we can do with it. Yeah, we could have it take a sketch of a template on paper or a Figma or mural design and turn that into a template. We could have it connecting to those data providers with MCP to say, I have a product that's to do with hot air ballooning. What data do you have that I can show my users? That might be interesting. Loads of stuff, anyway, all exciting. But fundamentally, what are the takeaways for any other project doing something like this? The only reason we could do this with as much success as we had was that we've got a strong architecture for the template model. We understand very well, we've defined the old-fashioned way, what our input data types are, what our output data types are. We're not prompting a larger language model or an agent like Codex with repeated prompts and trying to guess at our shape. We've told it, this is the shape we want, this is what you have to comply with, and then we've validated it repeatedly at every step of the way. The human in the loop is a feature for them. They have template authors. They've got regulations around a lot of this stuff, which means they can't just automate stuff into production. So what we want to do is automate the boring bits. We don't want to take responsibility or decision-making away from people that are doing it now, at least not yet. Maybe one day, but we'll see. And from our perspective, we built this on top of an existing system. We approached it as a systems integration, systems engineering problem. It's not really different. It's AI, but it's not really different from just the way we already build software. We can build features that can do new stuff in cool ways, but it's not it's exciting, but it's not fundamentally different if you take a step back and look at it more widely. So keep that in mind. There's lots of places to use this. You don't have to change everything all at once. Take advantage of the tools in different ways, and you can do different things. And that's it.
Well, thank you, Peter.